Okay, so we are in Statistical Rethinking, second edition, chapter 9, and we are on question 9E5. Okay, here's the question. So what value should R hat approach when a chain is sampling the posterior distribution correctly? Okay, so this book gives a little bit of information, but really just enough to answer the question. And so I'm going to go into a little bit more detail as to what R hat is and how it comes about. So straightforwardly, the answer is 1. So when you run your model, your MC model in Stan, or using the Ulam function with the rethinking package, you will one of the summaries that comes out is the R hat value for each parameter that is being estimated, and a value that indicates that there is convergence is 1.0. Okay, but it might be nice to understand kind of where this comes from. Okay, so if you're familiar with ANOVA, this will make a lot of sense. If you're not, you should still be able to follow along here. But ANOVA is a type of hypothesis test that's used in frequentist statistics, so not Bayesian, but frequentist statistics. Okay, and it's usually used to try to assess the differences between groups. So if I have 3 groups and they're all receiving a different treatment or 2 different treatments with one placebo or something like that, we can use ANOVA to try to determine if the difference between the groups is quote-unquote statistically significant. Again, that is vocabulary that comes out of out of frequentist statistics, not Bayesian statistics. But anyway, in the ANOVA world, in frequentist world, the test statistic from ANOVA is called F. Okay? And F is a ratio, and it's a ratio between the variance between your groups over a variance within groups. Okay, so this is what the F statistic roughly looks like. Okay, so the F statistic again is the variance that is measured between groups, and then within each of those groups, I also measure variance. Okay, and so if there's no difference between the groups, then the amount of variance you expect to be there between the different groups should be on par with what you see within the groups. Okay. However, if the groups truly are different, then we expect that the variance between the groups should exceed that of within the groups. Okay. So that's how the F statistic is being used. So when there is no difference between the groups, F should converge to 1, right? Because the numerator and the denominator would be the same value, or roughly the same value. And so in that case, when there is no difference, F equals 1. Okay? Well, this is what R hat is doing basically. But instead of assessing groups, the thing that takes the place as groups is the values of the posterior distribution that is visited by each chain of our model, right? So in our models, we're generally running multiple chains, and each one of these chains is kind of traversing posterior space. Okay, and so they're all going to visit unique values for the most part. Okay, so or different part. Well, anyway, so when if those chains have visited the same the same areas of this posterior space, well, then the variance between the chains should be the same as the variance within the chains, right? So if I'm measuring the variance of the values visited by each chain, both between chains and then a variance within the chains, again, if the chains have converged, then we should see that this ratio is about 1 because the 2 estimates of variance should be more or less the same, right? And so again, in this application, in the application of R hat, that would imply that the chains have visited the same areas of posterior space, right? Conversely, if they have visited separate pieces of posterior space, well, then the variance between the chains is going to be larger than the estimate for within chains. Okay, and again, this would imply that that there is difference between the chains. In other words, they have visited different parts of the posterior distribution. right? So again, when r hat equals 1, this means that convergence has probably taken place for exactly the reason that I've stated. If r hat is larger than that, then it implies that the chains are looking at different parts of posterior space and therefore have not converged. Okay, I hope that was clear enough.